Now we start our next chapter, that is chapter number 5. Chapter number 5, Arithmetic Progressions. So before we proceed, you need to understand the meaning of these two words. First is arithmetic, second one is progression. So first we start with this progressions. What does it mean? Progression means something which continues either in forward direction or in reverse direction. Means something should continue, then only if something is moving forward or backward, then only we'll say it is moving things. Progression means something is moving always. If it is stopping at some place, then we cannot say that is a progression. The next thing is arithmetic. And arithmetic means something, two things are being added or subtracted. Two or more things are added or subtracted, means involvement of two operations, that is addition and subtraction. Plus and minus, if it is involved, then such a combination, such system is called arithmetic system. Now, in arithmetic progression, so arithmetic progression means when something, pay attention here, each and every word is very important. When something moves in forward direction by adding something, by adding some constant in it, and it continues till the end, or when it moves in reverse direction by subtracting some constant or something from it, we get arithmetic progression. Okay, so here very important things, when something is moving forward means adding continuously into it, but that constant should be same only. For example, I'm standing at origin, and then somebody asked me to move with 10 inches. So one step for 10 inches. I cannot take more than 10 inch each time. So first at 0, then 10, then plus 10, 20, then plus 10, 30. Every time I am adding this constant, that is 10 in the previous one, and that is called forward movement. Similarly, if I subtract something from it, for example, I'm at origin 0, and then my direction is a reverse direction, so I have to subtract. So then minus 10, then minus 10 and minus 10, minus 20, minus 30, and so on. So this system is called, this type of progression is called arithmetic progression. Here we have the following three very important things for an AP. First is something. What is now something? I explain you. Something means something. Something means the starting point. Something moves means we are in the beginning where we were. So some starting points, and that is called in terms of AP first term of an AP, and it is denoted by small a. Remember it. The first term of any AP is called the starting point or the first term, and that is denoted by small letter a, first letter of English alphabet. The second thing is constant, which I spoke already. So constant. In this AP arithmetic progressions language, we call this constant as common difference and denoted by small letter d. Difference. Difference means the second term minus first term, third term minus second term, so on. That means next term minus previous term. That is called common difference. This is constant. What we were talking about, forward directions or reverse direction. So for an AP, in AP you have to identify these all terms. You have to mention. The third is end of that progression, end of that AP. So end is called in AP last term of progression or AP, denoted by AN subscript or TN, N is subscript only, again TN, N is subscript again, or small letter L, L for last term. Nth term is also called nth term. Okay, I hope this much is clear. Then a relationship between above three, that means starting point, this N, this T, this A, everything we are going to explain with the following relationship. A plus bracket start N minus 1 into D equals to this, I told you, equals to any of these three. You can write anywhere. Either you can write AN or TN or L simply. This all are same only. In some books, this last term is denoted by TN in some, while as in other books it is being denoted by AN. So you should not be confused what is this AN, what is this TN. TN means term, AN is also term, and L is also term. What is this all three denotes? What all these three denote? Last term of an AP. So this is a very important formula. A plus N minus 1 into D is equal to the last term. With this formula we will be solving many questions in this chapter. Okay, so A is here the first term, N is here number of terms involved in that AP, D is called common difference, AN or TN or L is called last term or nth term of an AP. So these all terms you need to remember. A plus N minus 1 into D is equal to AN, where A is the starting point, the first term, N how many terms are involved in that AP, D is the common difference of any two terms, second term minus first term, and the AN is the last term. Let us start now this exercise 5.1, which is very simple. Just a few questions on little application based. Just start. Exercise 5.1. The question number first says, in which of the following situations does the list of numbers involved make an arithmetic progressions, and why? Means in the following problems you have to just search out whether the numbers which are in increasing order or decreasing order, you have to find out whether it forms arithmetic progression or not, and if forms, then why. You have to give reason. The first one is the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. Let us go for the solution. Now the question, you must be clear about it, that the taxi fare for the first kilometer is rupees 15 and the remaining kilometers will be multiplied by 8. So the taxi fare for the first kilometer is equal to rupees 15 and the taxi fare for the first 2 kilometers means first kilometer 15 and then second kilometer is rupees, this 8 will be added. So 15 plus 8 is equal to 23. The taxi fare for the first 3 kilometers, first is 15, second is 23 and then 23 plus 8 is equal to 31. So clearly 15, 23 and 31 forms an AP because every term is 8 more than the preceding term. So this 15 and 23 and 31, as you can see, this is second term. This is universal law of identifying arithmetic progression. This is first term and this is third term. The universal law of identifying is any progression is AP if third minus second term, if it is equal to second minus first term. So look at here, 31 minus 23 is equal to 23 minus 15. In both the cases you will get 8 and here also 8. So we say that this taxi fare involved in this particular question and the subsequent association with the kilometers forms an AP. So clearly 15, 23, 31 forms an AP because every term is 8 more than the preceding term. So let us take one more question. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So let us go for the solution. The question is the amount of air present in a cylinder. So let the amount of air initially present in the cylinder equals to V cubic centimeter in the beginning. Therefore, the volume of air present in the cylinder after every stroke means one stroke is removing 1/4 of the air remaining in the cylinder. So in the beginning the remaining air is V. So the stroke which will be removing is equal to V by 4. So the first is V. First case it will be volume V only because that is present. In the second case the volume present minus 1/4 of the air of it, that is 3/4, and in third case the volume present is 3/4 and its 1/4 is 3/4 upon 1/4 which is equal to 3/4, 3V/4 minus 3V/16. If we take LCM then it is equal to 9V/16. So clearly the first, second minus first or the third minus second are not equal. So therefore it does not form an AP. In terms of general AP, before we proceed to the next question, you must know in general way how we write the general terms, that is first term, second term and the nth term. Nth term you are already knowing that a plus n minus 1 into d. In that formula if you put n is equal to 1, 2 and so on, you will be getting first, second and third, fourth and so on terms respectively. So the first term is, as we have mentioned, always denoted by a, and then common difference will be added like in previous question. What did we do? that the fare for the second kilometer was rupees 8, and then fare for the third and fourth and so on we had added. So similarly, the first term is a, the second term is a plus d, the third term is a plus 2d, the fourth term is a plus 3d. Similarly, the nth term will be a plus n minus 1 into d. So this is the way we will be writing all the general terms. So based on this, let us take another question. Write first four terms of the AP when the first term A and the common difference D are given as follows. A is equal to 10 and D is equal to 10. Look at here, A is equal to 10 and D is equal to 10. Now the value of A is 10 and the D is 10. So we will put this value of A and D in this second, this is third, and this is fourth, and so on. So we are asked to find out the first four terms. That means these are first, second, third, and then this is fourth. Okay, so we put this way solution. Since we have general terms a plus d, a plus 2d, a plus 3d for first four terms. So therefore, putting a is equal to 10 and d is equal to 10 in above, we get what we get: 10, 10 plus 10, 10 plus 2 times 10, because already here 20, 20 plus 10, 30, 30 plus 10, 40, and so on. So the first four terms are 10, 20, 30, 40. This is all about finding the terms when a and d are given. The next part of this question is fifth. A is equal to minus 1.25 and d is equal to minus 0.25. So again, putting these value in the above relations. Since we have general term again a plus d, a plus 2d, a plus 3d, so therefore putting a is equal to minus 1.25 and d is equal to minus 0.25 in above, we get what we get: a is equal to minus 1.25. And next term is a plus d. So a is minus 1.25 and minus 0.25. So adding these two negative terms, so minus 1.50. This is our term number 2. The term number 3 is the second plus common difference. The second term is minus 1.50, and adding into this minus 0.5, minus 0.25, that is this common difference, which is minus 1.75. This is third term. Now we are going for the fourth term. So fourth term will be again found by adding common difference into third term. So third term is minus 1.75 and then minus 0.25 is the common difference, so it is minus 2. So these are the first four terms, first, second, third, and this is fourth term. First four terms of this AP. First four terms of this AP will be minus 1.25, minus 1.50, and then minus 1.75, and at last minus 2. Next question. For the following APs, write the first term and the common difference. Now the question is, you are given a AP and you have to find out the first term and the common difference. Very easy. This is AP 3, 1, minus 1, minus 3. So now for the solution, the first term, as you can see here, this is 3 only, and the common difference will be second term minus first term. So 1 minus 3 is equal to minus 2. So this is D, common difference, and this is first term. So simple, very small questions. Next part of this question, 1 upon 3, 5 upon 3, 9 upon 3, and 13 upon 3. So for the solution, the first term is 1 upon 3, that is A, okay, and the common difference will be second term minus first term. 5 upon 3, this 5 upon 3 minus 1 upon 3, which is 4 upon 3. So this is first term, this is common difference. Next question 4. Which of the following are APs? If they form an AP, find the common difference. D. And write 3 more terms. Now you have to identify in the following progression whether it forms uh, an AP or not. If forms, then you have to find out the common difference and then the remaining 3 terms that you have already learned: A plus D, A plus 2D. Like that you have to put the value of A and D. First of all, you have to check whether it is AP or not. For that, the general concept I have already told you: third term minus second term must be equal to second term minus first term. If it's so, means if both are equal, then we say that the difference is common. So it is this progression is arithmetic progression is an AP. So for that, let us start. So we have 2, 4, 8, 16. So let us try to find out the concept. Before that, you just try to throw some light on this line. For any progression to be an AP, it must satisfy the following condition. What is the following condition? As I told you, third term minus second term, it must be equal to second term minus first term, which is called common difference and is denoted by small letter d. So let us check for this question. Now the problem we have, the third term is 8 and the second term is 4. So 8 minus 4 is 4, and then second term is 4, and then minus first term. 4 minus 2 is 2. As you can see, 4 is not equal to 2. So the difference is not common. Therefore, this is not an AP. That is end of the question. Next part, second number, 2, 5 upon 2, 3, 7 by 2. We have to check whether it is an AP or not. So third term, 3 minus 5 upon 2. 3 to the 6 minus 5, 1 upon 2. And second is 5 by 2 minus first is 2. So 2 to the 4, 5 minus 4 upon 2 is equal to 1 by 2. So as you can see, third minus second is equal to second minus first. So the difference is common. So that is also one answer of this question. Then the next 3 terms. First term is as we found here, the last term 1, 2, third, fourth term is here. Now the next 3 terms we are asked to write. So this last term plus common difference, 7 by 2 plus 1 by 2 is equal to 7 plus 1, 8 by 2, 4. Okay, and then that last term plus common difference will be the next term. So that is equal to 4 to the 8 plus 1, 9 by 2, and that last term plus common difference will be our next term. 9 plus 1, 10 by 2 is equal to 5. So these are the 3 next terms. Okay, so the next question, 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. Now for this, again the 3 plus root 2 minus 3. 3 plus root 2 minus 3. So 3 and 3 cancel. So it is equal to root 2. 3 and 3 cancel equals to root 2. Let us check. It is this we have written second term minus first term. Now we have to check whether it is third term minus second. It is equal to third term or second. So 3 plus 2 root 2 is our third term, minus second term, minus 3 minus 2 root 2. So minus 3 cancel. 2 root 2 minus 1 root 2 is equal to root 2. So here also root 2, here also root 2. So that means difference is common. So common difference is root 2. So that means this is an AP. Now this is an AP. So the next 3 terms, This is our last term, 3 plus 3 root 2. Then adding root 2 into it, we will have 3 plus 1, 4 root 2. Then next term will be 3 plus, again one more root 2 will be added, so 4 plus 1, 5 root 2. Then one more root 2 will be added, so 5 root 2 plus root 2, 6 root 2. That's all about this. Next question is 1 by minus 1 by 2 minus 1 by 2 minus 1 by 2 minus 1 by 2. All the terms are same. Now before we proceed for this question, actually you must know this concept. What is the concept? Uh, for Pay attention, for any progression to be an AP, its common difference can never be 0. Remember this, for AP, its common difference can never be 0. Otherwise, it is not a progression. That is, for example, 2, 2, first term is 2, second is 2, third is 2, everywhere 2, 2, 2. So, since common difference equals to, that is second minus first term, equals to 2 minus 2, that is 0. So the common difference is 0, therefore this is not an AP. Okay, so I hope this is clear. If it is clear, then we will go for this question. As you can see here, minus 1 by 2, minus 1 by 2, everywhere the terms, all the terms are same only. So in this case also we will have the common difference 0. Second term minus first term minus half plus half minus second term minus first term, minus into minus, this minus plus, so these two cancel, is equal to 0. Since the common difference is 0, this is not an AP. Okay, the next question is part number 12, root 2, root 8, root 18 and root 32. So this progression we have to check whether it is forms an AP or not. So let us go for the solution. This again that same format, second term minus first must be equal to third term minus second. So here we have root 8 minus root 2. So root 8 can be written as 4 into 2, square root of this thing. This can be written as 2 root 2. So 2 root 2, this minus root 2 will be equal to plus root 2. 2 minus 1, 1. So it is root 2. Now again similarly, we'll go for root 18. Root 18 can be written as 9 into 2. So that 9 can be written as 3 square root of 9 is 3, and then 3 root 2, and then minus 8 can be written again as 2 root 2. So 3 minus 2 root 2 is equal to root 2. So this root 2 and this root 2 both are equal. So that means the difference is common everywhere. So this forms an AP. So next three terms will be, as you can see here we have the last term is 32. So the last term plus common difference will be the next term. So root 32 means root 16 into 2, which is nothing but 4 root 2. So 4 root 2 plus root 2, 5 root 2, 5 root 2 plus root 2, 6 root 2, and then so on 7 root 2. So these are the three terms, next terms, 5 root 2, 6 root 2 and 7 root 2. The next part is part number 14, 1 square, 3 square, 5 square and 7 square. Let us check whether this progression forms an AP or not. So go for solution. second term minus first term. Second term is 9. 3 square of 3 is 9, minus 1 is equal to 8, and second third term minus second, that is square of 5 is 25, and minus 3 3 is 9, so is equal to 16. Clearly 8 is not equal to 16, therefore we can say that this is not an AP. So 8 is not equal to 16, therefore it is not an AP. So that's all about this question. And exercise 5.1, here we complete the exercise 5.1.